recording. Okay, so we talked about, we're basically talking about the first two cases over here, how to use law of sines to solve, when you know two angles and one side of the triangle, or two sides and an angle that is opposite from them. So those were the two different cases that we were looking at. And then for numbers 3 and 4, where you know the three sides, or two sides and an included angle. So the difference between case 2 and case 4 is this is two sides and an angle opposite to one of those sides. This one here is two sides and an included angle. And that's what we're going to solve using law of cosines, which is going to be in section 3.2. Oops. Okay. So what we had talked about was just different examples on how we can solve these cases. One example I wanted to show you was part of this ambiguous case where, in what situation would you end up where you don't end up with a triangle at all? This is one of those cases where you are just not satisfying any of the conditions. And we had looked at an example of this in our handout, but let's look at an example through our textbook over here. So we are looking at number, I believe it should be 25, but we'll have to solve it to see what it ends up looking like. So again, your instructions are saying use law of sines to solve, if possible, the triangle. If two solutions exist, find both. And if you do get answers, round them to 2 decimal places. So in this case, remember the best way to check is, of course, your given angle has to be an acute angle and the value of A has to be less than H. And H is defined as side B times sine of angle A. So, that way you can kind of check and see, which case we are going to fall into. So let's get into number 25 here. So you can see we're given the angle 76. It's definitely acute. And then you have A equals 18, B equals 20. So let's go ahead and see what that B value comes out to be. So you can see this is the definition for B. So that's going to be side B is 20 times sine of angle A, which is 76 degrees. And what will this come out to be? Again, make sure your calculator is in the right mode. And looks like approximately this guy is coming out to be 19.4059. Yeah, Savannah, very nice. Okay, Savannah, yeah, I just saw your other message also. Thank you for letting me know. So rounding it to 2 decimal places, this would become 19.41. So your condition was, is A going to be less than H? Again, kind of looking at our notes over here. So is A going to be less than H? And as you can see from our example over here, that A is only 18 and your H value came out to be 19.41. So you can see this is going to be true because your A value is smaller than your H. So this is going to be one of those situations where you are not going to have a triangle. So this will be that situation. And you can kind of see that with this also, no solution. So in these cases, and you can check for these before you start solving. If you start solving it, you can kind of see, again, am I going to get an answer? So, if you're using law of sines, which was this over here, you can try and see what happens when you start solving with this, and you won't get an answer. So that's kind of what happens here. I'm just showing you by checking to see if your H value is larger than your A value, and that itself, that little calculation will let you know if you need to move forward or not. So questions on this example here, guys? because we had done the two cases and the single case last time. So this was the only one we hadn't talked about. So I wanted to make sure you at least saw an example of this. Now, the other part that we get into, let's clear this guy out. Okay, there we go. So for the other part was where we were actually getting into finding the area of these types of triangles. So here they're saying the procedure used to prove the law of sines leads to a formula for the area of an oblique triangle. And they're just showing you what those two triangles might look like. So they're, again, same relationship. They're showing you that the height for each of the triangle, and that's going to be this perpendicular height, you know, when you go from the base of the triangle to the, vertex on the top. So that's the perpendicular height that we are talking about as the h. So we're saying the h value is going to be b equals, h equals b times sine of a, which is the same property we were using for our little case above that we looked at. So based on that, and what we know of the area of a triangle, try to keep that together if I can. We know the basic definition for the area of a triangle is 1/2 base times height. So when you think about, your triangle, let me see if I can get that image in here. So when you think about this triangle over here, you can see our base is C, that's the bottom of the triangle. So that's the 1/2 from your definition, the C from your base, and then the height is that perpendicular height that we're talking about, which is defined as b times sine of a. So that's where this, area definition is coming from, 1/2 b times c sine of a. Now, you don't have to always take C as the base of your triangle. This can keep changing depending on, which side ends up being on the bottom, because, if we are labeling this, we're not necessarily always going to label C, on the bottom of our triangle. So they actually go through this whole iteration where they're showing you, just depending on how the triangle is set up, you can actually modify that formula. So yes, we do have the 1/2 BC times sine of A like we did up here. But if those labels change, you can have 1/2 AB times sine of C or 1/2 AC sines of B. So the best thing to remember is whatever two sides you are using, remember you have sides A, B, C and angles A, B, C. So whatever two sides you're using, the third side, that's the angle you will be using, right? So if you're using sides A and B, that means you're using angle C. If you're using sides A and C, then you're of course using angle B. So that way you can see all A, B, and C are represented, but two of them will be the the sides, and the third one will be the angle. So that's kind of how you can remember, this formula for the area of an oblique triangle. And then in this little remark over here, they're just kind of going through, how they came up with the height, the H value for the triangle. So you can kind of look through this also, just to see that explanation. But that's the basic area of the oblique triangle that you will be using. And we'll actually be learning a new formula in the next section also. It's called the Heron's area formula. So you'll actually be seeing just another one also. So literally you have like 3 different formulas for the area of a triangle that you can technically use. So let's take a look at an example for this guy over here. They're actually also showing you that this area would also work for a 90-degree triangle also. So let's take a look at this guy here. This is talking about find the area of a triangular lot with 2 sides of length 90 meters and 52 meters and an included angle of 102 degrees. So as you can imagine, the 102 degrees is going to be the sine of your angle, and then the 2 sides you'll be multiplying with 1/2. So just put that into the formula, throw that into your calculator, and you end up getting your area of a triangle. So literally as simple as, plugging it in. Now there's another example here if you wanted to look at, but let's see how we can apply this to our application. So this one here is talking about the course for a boat race starts at point A. So that's of course point A here. Proceeds in the direction of south 52 degrees west. So again, that's your bearing. So you can see using, again, remember when we're doing this over water or land, we always do the north-south line for our bearing. So that's this north-south line over here. So when you're going 52 degrees southwest, that's the 52-degree angle you're making, and you're moving to the second point where the boat heads. And then they are saying in the direction of southeast, 40 degrees, that's going to be this north-south line. And then from there, you're going 40 degrees in the southeast direction to point C. And then finally, the boat goes back to its starting point, point A. So they're saying point C lies 8 kilometers directly south of point A. So we know that distance between A and C. They want to know approximate the total distance of the race of the course. So, we know this is 8 kilometers, but then what are these two other distances over here? So this is where, again, we bring in the law of sines to help us out. And you can kind of see we are using a little bit of geometry to help us out again, because these two lines make a parallel line. This is a line that's intercepting both of them. So again, remember this angle is going to be the same as this angle over here. And that's where they get this 40-degree angle on this image on the right. And we've done this a couple times now, so I'm kind of hoping that you're getting used to this little bit of geometry at this point. Alrighty, so let's see. As you look at this solution over here, they're talking about the lines BD, which is going to be this one, and AC are parallel. They're talking about how those angles are congruent to each other and all of that. So that's kind of where this math is coming from. And then, of course, using the idea that all three angles in a triangle add up to 180 degrees. If you subtract 52 and 40 from it, your angle B over here will come out to be 88 degrees. So that's the last part they're talking about here. So we know all three of our angles over here. So using our law of sines, we should be able to find these two missing sides, which they've labeled this as side A because that's across from angle A, and this is side C because again, that's across from angle C. So you can see over here, they ended up taking for side A, we're basically using this formula over here because, again, we know this side, right? We know this is 8 kilometers over here. So as long as you have two angles and one side, we're able to use law of sines. So again, just take that sine of 52, multiply it to the other side, get rid of it from here. And you end up with, throw that into your calculator and you're getting approximately 6.31, and this will be kilometers for side A. So that's going to be this side here, which is approximately 6.31. And then, of course, using that same formula, we basically just switch it, and to find side C, we go this way. So again, multiply both sides by sine of 40, get C by itself, and this is coming out to be approximately 5.15 kilometers. And once you have those two sides, add all three of them, and approximately the boat traveled a distance of 19.46 kilometers. So just again, how you can use this in an application. There's another example here, kind of similar to the one we just talked about. So you can take a look at this guy if you like. And let's pick one from our textbook here. Okay, so this one actually is talking about finding the area of our triangle, and we're looking at number 43. Okay. just for a practice, let's take a look here. So finding the area is going to be 1/2. And then in this case, you will notice we are actually given 2 angles and 1 side. And in our area of a triangle, you need 2 sides and 1 angle. So, you would either need A, B, and sine of angle C, or, something like that. So before we can actually do the area, we need to calculate one of the missing sides. So where do you think we should start with this example, number 43? Because you're given angle A, you're given angle B, and you're given side A. Yeah, Andrew, very nice. We do want to start with law of sines. And since we are already given angles A and B, it obviously makes sense to find side B first. So again, let's see, we're finding side B. So we want to keep the sides on the top. So A over sine of A equals B over sine of B, right? A is 8. Sine will be for 67 degrees. We're finding B, and this will be sine of 43 degrees. So again, to get B by itself, guys, we would multiply both sides by sine of 43. So that would cancel out on the right-hand side. We would be left with just B. And can you tell me what that side B will come out to be? And they're asking us to round it to 1 decimal place. So let me see what your answer comes out to be for side B, rounded to 1 decimal place. All right, Lucy, you've got 5.9. Andrew, you have the same answer. So let's do this as an approximation. The answer we're coming out with is 5.927. So yeah, that will round up to 5.9. Okay, now that we have found the second side, now what will we need to do to find the area? Because we now have side A, we have side B. Let me see if we can go back to our notes here very quickly. Okay, so you are actually looking at this form of the formula because we have sides A and B. And remember, the 2 sides that you have, the angle is going to be the third one. So that means we actually need to find angle C first. So can you tell me what our angle C is going to be? Okay, very nice. I've got 70 degrees from 3 of you. So that's going to be 180 minus the 67 degrees minus the 43 degrees, which is adding up to what, 67, 70, 110. So yeah, that will come out to be 70 degrees. Perfect. So now we can do area is 1/2 A times B sine of angle C, which will come out to be 1/2. A was 8. B, as we rounded it to 5.9, and then sine of 70 degrees. So what are we looking at for the area of this triangle here, folks?
I got 22.17.
Okay.
22.2.
All righty. Did anybody else have that same answer? or if you had a different one than what Lucy told us. Okay, Savannah. All righty, very nice. So, and the difference is going to come where we rounded the answer B. Now, if you did not answer B and you left it with all its decimals, you would have a little bit of a different answer. So anytime you round your answers, it is going to make a difference. And so in this case, since we left it at 5.9, and if you had left it at 5.927 and there were a few more digits after that, your answer would be a little bit more accurate. So let's see. Yeah, it does come out to be 22.176, which again will round to 22.2. And let me just show you very quickly what happens if we did not round our answer. Let's go to our scientific calculator here. For B, make sure we're in degree mode. Okay. So we are doing sine of 43 degrees multiplied by 8 divided by sine of 67. So you can see this came out to be 5.927, 167,967. I'm going to copy that over. And then let's do for our area. So that was 1/2 multiplied by 8 multiplied by our B value. So I'm going to keep all those decimals. And then we multiplied it by sine of 70 degrees. And I know it's kind of obscured in here, but it's coming out to be 22.278864. So again, you can see the more decimals we have, a slightly different your answer is, because now when I round this actually comes out to be 22.3. So those decimals make a big difference. So just to let you guys know, as you're working through your homework, if it keeps giving you an error, it could be that you rounded it too early and you didn't need to round it. And you can see that's what the correct answer is also showing as 22.3. So it might be better for us to not round this answer. Maybe leave it with all those decimal places. So when we put it in here, probably leave the 27 in there. So this would give us a little bit more of an accurate answer here. So yeah, just be very, very careful with those, sub rounding, like if you're rounding too soon. All righty. Questions on this one over here, guys? So like I said, it's literally just about plugging in numbers, but this example was a little bit different because you did have to find, the angle C and the side B before you were able to actually get to the area of the problem itself. Okay, let's save this. Okay, so that brings us into law of sines. These are the other two cases that we were talking about. So this is where you may be given all three sides, or you may be given two sides and an included angle in that. So law of cosines obviously looks quite a bit different than law of sines. So these are your standard form and the alternative form for the two. Well, it's the same formula, it's just being rewritten. So all they have really done is isolated the cosine of A, cosine of B, cosine of C, and then, basically moved everything else to the other side. And they've kind of rewritten these formulas. So they're the same formula, just in two different forms. Okay, so let's look at our first example here. This one is where you are given all three sides of your triangle, and you're finding the missing information. So you can see we're given A is 8 feet, B is 19 feet, C is 14 feet. Remember what I told you guys last time, the angle measurements will be the same in ratio as the side. So the angle across from side A is going to be the smallest one. The angle across from side B is going to be the largest one. And of course, C is going to be in the middle. So in this case, since you are finding angles, you want to use the alternative form, right? Because this one is more for the side A, this one is for angle A. So we are using, and you can use them in any order you like, but they started out with finding the largest side first. And that's what I recommend, is go with the largest side or the largest angle first. So that's why they went with side B or angle B. And so cosine of B is a squared plus c squared minus b squared divided by 2ac. And this is where you plug in all the different measurements for the three sides. Throw that into your calculator and whatever you come up with. Just remember that this needs to be in parentheses when you're typing this in your calculator, and this will also need to be in parentheses when you type this into your calculator. So we are getting negative 0.4509. And remember, this is because it's showing up in, is this by default in radians, or do we, once you do the cosine, arc cosine, it will come out to be, let me check. So if we did arc cosine on negative 0.4509. Okay, so as long as your calculator is in the correct mode, you should be okay. So yeah, once you do the arc cosine on this number, you will be able to come up with the approximate value for your angle B. And then they are saying you can actually go ahead and use law of sines to find the other angle. So you, in this case, they are using the form sine A over A is equal to sine B over B, and then just multiplying both sides by A and isolating the sine of A, and you end up with A times sine of B over B. You know, plug in the values you know with the angle we just calculated, and that gives you sine of A. Obviously, we will again do arc sine to find what angle A is going to be, which comes out to be approximately 22.07. And then for the last angle, just subtract the 2 you found from 180, and that will give you angle C. So as you can see, we only use the law of cosines to find one angle. And once you have that angle, you have all the three sides, you can go back to law of sines to find the missing information, you know, one of the other angles, and then just use basic geometry to find the third missing angle. So again, you've got another example over here to help you out with that. Let's take an example here. Okay, so there we go. This one, the instructions are basically use the law of cosines to solve the triangle, and we're rounding our answer to 2 decimal places. And the example we're looking at is number 15 over here. Okay, so as you can see, we're given our three sides. A is the largest side, which means A will be the longest angle. B in the middle, C would be the smallest one. So let's start by finding, I guess the longest angle would be A. So we will do cosine of A. And again, there is actually a way you can kind of remember these formulas, if you will. So when you're talking about cosine of A, you actually start with the other two sides first. So since you're finding cosine of A, you will do B squared plus C squared. So those are the B and C. The angle A itself is the side A that gets subtracted. So you can see when you're finding angle B, it's the B side that's subtracted. For C, it's the C side that's subtracted. So like I said, it's the two other sides that you are adding first, and then the angle, the side that corresponds with the angle is the one you're subtracting, and then divided by 2BC. Again, the two sides that are not part of the angle. So that's kind of the format for these formulas over here. And, of course, you guys are allowed a cheat sheet, but, these are just some ways that I can remember the formulas without having to look at them. But so you've got this. So let's go ahead and plug this guy in. Okay, I actually need to go here. Alrighty, so b squared plus c squared minus a squared divided by 2bc. So our side b is 1.8 squared. C is 0.9 squared minus a is 2.5 squared, and then divided by 2 times 1.8, 0.9. And remember, this will give you cosine of A. So let's see, what will this come out to be? So once you have your answers, go ahead and share them with me in chat. And then remember, once you find the answer for cosine of A, you will do the cosine inverse or arc cosine to find angle A. And you don't want to round the cosine A answer that you get from solving this fraction, because just like I showed you how you can end up with rounding errors, round when you find angle A, not before then. So this is kind of what my calculator is showing. And you're rounding to 2 decimal places in this. Okay, so what do you get for your angle A? Yeah, so Andrew, you do want to start with the largest angle first. So whichever is the longest side, that will tell you which one is going to be the largest angle. And so that's where you always start, is by either finding the longest side or by finding the largest angle first. Yeah, that was a good question. Okay, so Lucy and Andrew, you both got 132.77, and that's also what I came up with. So 132.77, and after that, sorry, you actually had 7,665. So when you round it, you will end up with 132.77, and this will be in degrees. Okay, Darren, very nice. All righty, so everybody's on track with this one. That's going to be angle A. Now that you have your angle A, technically for angle B, which is the next in line, you can use law of cosines, or honestly, like we saw in the example, you can also use law of signs to find this. So it's up to you what you want to use. If you want to use sine, then, you know, of course, this will be the formula. So that means you would basically end up multiplying both sides by b. Which would end up giving us, let's see, sine of A would be 132.77 degrees. Side A was 2.5. Side B was 1.8. So sine of B would be what? And, you know, if you go the cosine route, then your answer will be, you know, based on the cosine. Since we ended up using law of sines, this answer is going to be different. So you have 0.528541.573, and same thing, you will have to use arc sine to get B by itself. So what angle measurement do we get for angle B? Alrighty, Andrew, you've got 31.91. Did anybody else have that answer? Yeah, alrighty, very good. Let's see, Savannah, alrighty, perfect. So again, the raw answer is 31.9069, and it keeps going. But rounding it to 2 decimal places will give us 31.91. Alrighty, perfect. Ooh, running out of space here. For angle C, of course, we can now do just 180 minus the 31.91 minus the 132.77. And as you can imagine, this will come out to be a fairly small angle. So what does C look like, guys? And you can see side C is basically half of side B. So yeah, the angle would also reflect that. Very nice. So I've got 1532 from all of you. Very nice, guys. Good job. So now we have our 3 sides and our 3 angles. And again, you should be able to verify your answer. Any questions, guys? Okay, so that was given 3 sides. How can we find the 3 angles? So they're actually showing you here why it makes sense to go with the largest angle first, because they're showing, knowing the cosine of an angle, you can determine whether the angle is acute or obtuse. So, you know, if you have a positive angle, cosine is a positive number, then we know that measurement is going to be somewhere between 0 and 90. If cosine of the angle is less than 0, which means it's a negative, that is going to be between 90 and 180. And we kind of saw that over here, because our cosine of B came out to be a negative number. Our angle came out to be between 90 and 180 degrees. So when cosine is positive, you will have an acute angle. When cosine is negative, you will have an obtuse angle. So they are saying, you know, after you find the angle B is obtuse, then you know that both the remaining 2 angles would have to be acute. And that's the same thing that happened in our example over here. Angle A was the largest one. It came out to be obtuse because we also had a negative answer in ours. So based on that, we knew, okay, B and C both had to be acute angles, and that was definitely true in our example also. So that's kind of why they are saying, it's always better to start by finding the largest angle first and then working backwards to the other two angles. This one over here is the second case where you are given two sides and the included angle. So as you can see, we are given sides B and C, and the included angle is angle A. So in this case, you use the standard form of the law of cosine. So you have A square equals B square plus C square minus 2BC cosine of A. And you will see in this case, guys, since we were given angle A, we start out by finding side A. So you know sides B and C, and basically B and C are known. So we are able to, fill in all of these, and then you end up finding side A. So they plug in the numbers, go through the formula. Since you have A squared, we will have to use square root to come up with the length of the missing side. Now remember, guys, anytime you bring in a square root, you get one positive and one negative answer. But since we are talking about the side of a triangle, of course, any kind of distance cannot be negative. So that's why we end up discarding our negative side or the negative answer, and you just stay with the positive one. And then once you find that missing side, then you can obviously go back to law of sines to finding the missing second missing angle, and then 180 minus those angles to find your third one. So this one over here is again saying because your sine of B came out to be 0.7034, you can again actually end up with two angle measurements. Because as you can see, one of them is a fairly small angle, 44.70. So you have enough left behind that you can actually have a second value for angle B. So you do come up with two values for B, which will lead you to having two values for C. But then they say, since we know C is the longest side of the triangle, so coming back to our diagram over here, C was 12, B was 9, and A, of course, came out to be 5.4072. So this tells us since C is the longest side, that means C has to be the longest angle, which means B cannot be the largest angle over here. And that's why that calculation does not work out. C has to be the largest angle, which means C would end up then being 110, which means B would actually end up becoming 44.70. So this is kind of where a little bit of that critical thinking aspect is coming into play, because if you just go with the math calculation, then you may not realize, oh, my angle B came out to be 44.70, which means technically I can actually have a second angle which would satisfy that same condition. And this is kind of the thing that we had talked about in that ambiguous case over here. Hold on a second, let me move this guy. So, when we had talked about these two cases over here, this is exactly what we had run into, because we had said, your angle could be this, but because between 0 and 180, there would be a second angle that would satisfy that, you can come up with, two different possibilities. So that's kind of what's happening over here also. Oh, come on, buddy. Oh, hold on. So that's why you have to look at, how those sides are defined. And then based on that, you have to decide which one of these measurements makes more sense for angle B and which one would make more sense for angle C. And like I said, since longest side was angle C, which means side C, which means angle C will have to be the largest angle. And that's how you decide on these two. So you've got another example over here helping you out with that, but let's pick an example from our textbook to solve. So let's see, we did 15. Let's do 23 next. Alrighty, so for number 23, we are given angle C and we are given sides A and B. You know what? I think I'm going to transfer this to our notebook. This one may need a little bit of space. Okay, so we are given angle C, which is 43 degrees. We are given side A, which is 4/9, and side B, which is 7/9. Okay, so obviously, since you are given sides A and B and angle C, we want to start by finding out C square, or side C. So the third formula over here. So A square plus B square minus 2AB multiplied by cosine of C. So A square plus B square minus 2AB. So you can see all of those two sides, go together, and then you're just doing the angle, the cosine of angle C. So when we plug in, this will be 4/9 squared plus 7/9 squared minus 2 times 4/9 multiplied with 7/9. And of course, you're still multiplying cosine of 43 degrees. For this one, you can convert this to a decimal. You don't have to leave it in fraction form. So you don't have to worry about common denominators or anything like this. I would just plug this into my calculator. Make sure you are making your calculator understand that all of these are being multiplied into each other. So this will come out to be an approximate answer. And we are again not going to round till we do the square root of the answer to get C by itself. So I would recommend using parentheses around those squares so your calculator knows you're squaring the whole fraction and not just one number. All righty, Lucy. 0.09, sorry, 0.2968. Okay, so this is what my calculator is showing, and you will literally just do a square root on that. And remember, you are discarding the negative answer and just keeping the positive one. So when you take a square root on this number, that will actually give you what your side C will be. And what was our rounding on this? 2 decimal places. So what are you getting for your side C?
0.54.
All righty, very good. I'm going to write this in cursive so it looks a little like the lowercase c. So your raw answer comes out to be 0.5448, and it keeps going, and rounding it to 2 decimal places, we would have 0.54. So now we have the 3 sides of our triangle. And if it helps to see which one is going to be the largest side, you can convert these into decimals too. So side A is basically 0.444 repeating. Side B, again, if you convert that, is going to be 0.777 repeating. So that should give you an idea of, which is going to be the longest or the largest angle over here. So which side is the longest?
B.
B, very nice, which means angle B is going to be the largest angle in this case. So we already have C, you need to find A and B. And again, for that, you can use law of sines, because we already have 3 sides, 3 sides and 1 angle. So you can use law of sines to find that if you want. So let's see, if you want to find B, you can do sine of B over side B, sine of C over side C. Then again, you would multiply both sides by B, so we can get sine of B by itself. And that would be sine of 43 degrees divided by side C that we just found. Side B was 7/9. So again, go ahead and tell me what angle B comes out to be when you clean the whole thing up. That's not what the answer should be. And I think part of that is because we're rounding our side C over here. Okay, let me check something very quickly. Okay, so if we actually left this at 0.544831979, what would happen? $76.80, is that what you got? That still doesn't sound right. Okay, because that has to be the largest angle, because if we did, even with our original answer, if you had 7920, 7920 minus the 43, you would have 57.8, which, yeah, I guess it is the largest angle, isn't it? I guess with the unrounded, okay. Yeah, so that's kind of what I'm thinking, because then this number here will actually change if we use the longer number here. So sine of 43 divided by 0.544831979 multiplied by the fraction 7 nines. Yeah, so this number then comes out to be 973590372. And then when we do sine inverse on this, yeah, so it makes a little bit of a difference in your answer. And rounding it to 2 decimal places, what will that be? 7680 degrees. And then for angle A, just a simple math. Which will then come out to be let's see, 60.2 or 20, I guess, if we do 2 decimal places. Yeah, so as long as angle B comes out to be the longest angle, because that was our largest side. So angle B, then angle C, and then the smallest one should be angle A. See, but then angle A, that's 0.444. This is coming out to be 60. But the math looks fine to me. I don't think I made a mistake in the math. Why is this? Okay, so I just realized something. When I do this law of sines with angle A instead of angle B, we are actually getting a different answer for angle A. Okay, so that was sine of 43 divided by the whole long value for side C, and then multiply that by side A, which was 4 nines. And this is actually coming out to be 0.556337355. And then when I do a sine inverse on this answer, it's giving me the angle 33.8028, which will round up to 33.80. And that makes sense because that has to be the smallest angle, since that is the smallest side. So I'm kind of interested in seeing why when we did this with sine B initially, why that did not work out, because this doesn't make sense to me. So I might have to look into it and see why the answers didn't come out to be right, even though we did it, using basically the same formula, just different angles. And then when we do 180 minus the 3380 minus the 43, that will give us the largest angle, or B. And this might be a matter of, again, how you can have two different angle measurements with two different values, because, technically for A, we are getting 33.80. Well, if we did 180 minus 33.80, the other value for angle A, which you can call it as, A2 would come out to be 146.2. And then based on that, if you did, the second angle, that would be 180. No, that wouldn't work, would it? 146.2 and 43 add up to more than 180. So that angle wouldn't work. Yeah, I might have to look into it, guys, and see why when we did it the other way around, angle A did not come out to be the smallest. But this is making more sense because, like I said, B is the largest side, which means this has to be the largest angle. A is the smallest side, so A has to be the smallest angle. So this is what your answers have to look like. So again, kind of that critical thinking comes into play, because we have to let the measurements of the sides and angles guide us in knowing if we are getting the right answer or not. So some of these, like we started with B, that didn't work. So we had to come back and do angle A first and then subtract the two angles to find angle B. So questions on this example over here, and let's make sure our answers look okay. Yeah, so see, that's what the answers needed to be: 3380 for A and 103.2 for B. Alrighty, so that is using the alternative and the standard form to find our missing angles or missing side and angles. Okay, let's see. Are we quite ready for this example yet? Okay, so this one here, we're basically just getting into applications at this point. So this one is showing the pitcher's mound on a women's softball field is 43 feet from the home plate, and you can kind of see those measurements in the diagram. And the distance between the bases is 60 feet. The pitcher's mound is not halfway between the home plate and the second base. How far is the pitcher's mound from first base? So that's that distance H that they're showing you in the diagram. So, obviously you can see all four sides are making up a 60 feet distance. And we know from, again, basic geometry, if all four sides are the same measurement, it makes a square. And if you have a square, then all the corner angles are going to be 90 degrees, right? So if all the square corner angles are going to be 90 degrees, well, if you dissect it halfway, each side is going to be 45 degrees. So that's where that 45-degree angle is coming. So basically you can see we're making triangle out of this. One side is 60 feet, the other one is 43 feet because they told us that. And you're finding the third missing side. So basically, again, you can use law of cosines to help you out. So, they're naming that as H for the home plate, P for the pitcher's mound, and F for the first base. So using that, they've got your triangle HPF, angle H is 45 degrees. The length F is 43 feet, length P is 60 feet. We're finding the length H. So they're basically just modified by putting in the new variables in, but you're basically using the standard form of the law of cosines because you're basically given side, and the included angle, right? So that means you are using law of cosines to solve this. That gives you h squared. Take the square root of h and you are getting approximately 42.43 feet for the distance between the pitcher's mound and the first base. So just how you are using law of cosines in an application. Here's another one where we get into the alternative form of the law of cosine. So this one again is saying a ship travels due north and then adjusts its course. So basically it started out going straight, north, adjusted course. After traveling 80 miles in the new direction, the ship is 139 miles from its original point of departure. So they want us to come up with the bearing from point B to point C over here. So, obviously the idea is they want us to find what this angle over here is going to be. So we know that the distance from where it changed its course, it went 80 miles in the new direction. So since this is side, technically across from angle A, they're calling this as side A. Which is 80 miles. We know the angle opposite is B. So the side across from that is side B. That was the longest distance, 139. And then C is, of course, the initial distance the ship traveled north, which was 60 degrees, which ends up becoming side C. So technically, we have all three sides of the triangle known to us, and now we're working on the angle. So again, you want to find the largest angle first, which will also help us with our bearing over here. So plug that into the alternative form of your law of cosines. We get cosine B as this value. When you do your cosine inverse, we get 166.14. And the idea is, this is a straight line, which means it's making a 180-degree angle. If this little angle here comes out to be 166.14, all you have to do is subtract that from 180 degrees to find that other angle over there, which comes out to be 13.86. Putting it in the notation of your bearings, you are of course going north and the ship turned left, which means you are going in the direction northwest, and that's northwest with a bearing of 13.86 degrees. So again, just how can we calculate that using law of sines and cosines? And this one, of course, is focusing on law of cosines. So another example for you to work out over here. We'll come back to the area formula in a minute, but let's do a couple more examples just to make sure we're comfortable with this, how much ever time we have. Let's look at this guy. And I kind of like this problem because it's asking you to choose whether you have to use law of sines or law of cosines to solve the triangle. And, of course, if it's possible, because remember with law of sines, we have that ambiguous case where you may have no triangle, one triangle, or two different cases that are possible. So that's kind of what you have to think about. Again, we're rounding to 2 decimal places and we're looking at number 33 for this guy. And we'll move this again over to our notebook to solve this guy. So we're looking at 33. And let's see, we are given angle A at 24 degrees, side A at 4, and side B at 18. Again, if you draw just a normal triangle, and it can be something like this, it can be something like this, so just whatever you want to think about it as. And I'm kind of randomly labeling this now. We may have to change our labels later on, but we are given angle A 24 degrees, side A, which would be across from that, which would be 4. And B, since it had 18, I kind of gave it the longest side and the largest angle for now. So B would be 18, which would of course make this side C. So looking at what is given to you would you use law of sines or cosines? And again, you use, if you are given two angles on any side, or if you are given two sides and an opposite angle, you use law of sines. If you're given three sides, which is not our case, two sides and an included angle, you use law of cosine. So what would this be? Sines or cosines?
I think sines.
Yeah, because it's not an included angle. For the included angle, if you are given sides A and B, then they should have given you side C, because that is the included angle, right? Because that would be these two sides. Come on, buddy. That would be these two sides, and then that would be the included angle, and we don't have that. So this is going to be law of sines. So for law of sines, because again, you are given two sides and an opposite angle, this is actually the ambiguous case. So you want to think about what that height h is going to be. So remember, h is b times sine of angle A. B is going to be 18, sine of A is 24. And what will this come out to be? And remember, we're trying to establish if A is going to be less than H or not.
I got 7.32.
All righty. So yeah, I mean, Savannah, all righty, very good. So same answer as Lucy. So even if we rounded it to, you know, 2 decimal places, you can definitely see that yes, A is a value smaller than H. And remember, when this happens, you have no triangle. Because this is that first type of ambiguous case where A is smaller than H, you have no triangle. So again, you are choosing if you have one answer, two answers, or no answer. And this is the one where we ended up with no answer at all. So you've got a couple different examples like this in your homework where they will ask you to choose between law of sines and cosines. So it may not be a bad idea to have this little, you know, chart kind of open so you can see for the first two cases it's sines, second two cases it's cosines. Okay, let's take a look here. We may not actually have time for this. I had actually picked a couple application problems for us to work on, but we can do that next time. And then we'll also talk about the Heron's area formula. So literally we'll do one more application from law of cosines and then look at how to use Heron's formula, because this one is actually based on when you are given the three sides of the triangle, you don't have any of the angles, and just based on the three sides, how we can find the area of a triangle. So we'll look at that example and then we'll be done with cosines over here, guys. And then, you know, we still have chapter 4 that we need to talk about. Now, chapter 4 technically has 3 sections, but section 4.1 is like a review section. So we'll not be spending too much time of it. You know, just make sure you have a good base, good background, and then we'll get into 4.3 and 4.4. So let's see how things go on Wednesday, because right now 18th is when we are scheduled for chapters 3 and 4 exam. But if on Wednesday, it seems like we need a little bit more time to spend on chapter 4, we may move that date instead of the 18th to the 20th. But let's see how Wednesday goes. Because again, I don't want to rush through any chapter or anything like that. If we need to move the exam, we'll move the exam. So let's see what Wednesday looks like. But if you guys have any questions, any concerns, let me know. You know, keep working on your chapter 3 homework. You should be able to tackle 4.1 on your own if you want to try, but if you want to wait till we get to it, that's fine. Also, just don't fall behind on chapter 3 homework. And then I'll be happy to answer any questions you guys have. And if not, I will see you on Wednesday. So have a wonderful evening, guys. Take care, and I'll see you on Wednesday. Be careful.
Thank you. See ya.
Thank you. Bye-bye.